Welcome everyone. It's a pleasure to have all of you here on this webinar with us today. Uh, so, and I'll just take a few moments to run you through the agenda that we planned for today. For people who are joining us for the first time, I'll do a very quick company overview, the organization that we belong to. After that, we'll do a 5G network in a box overview, where I'll just provide an introductory talk on what the product is, and we'll also show you what the product actually looks like. Following that, we'll do a very quick introduction to the 5G core itself, which is one of the major components that make up the network in a box product. And then we'll describe the demo setup, the scope, and jump into the live demonstration. We'll wrap it all up with a Q&A session at the end of the session, and we'll try to wrap it up in 45 minutes. So, who are we? We are Amantya Technologies. We are a product engineering organization, and our focus essentially is to work across the spectrum, right, from the device to the RAN to the edge to the cloud. We develop solutions across the entire spectrum. We are a bunch of about 350 engineers, and we have offices in US and in India both. We are also a part of an increasing and large ecosystem and a growing ecosystem of the which encompasses the 5G technologies, namely O-RAN. And we also have a growing ecosystem of partners that we use to provide solutions that we incorporate into our products, right? Now we talk about the 5G network in a box. Now we talk about the 5G network in a box product itself. The product, as the name suggests, is nothing but an all-in-one solution with a pre-integrated 5G core and a 5G NR gNodeB. So the point to note here is that we are just doing this product for the FR1 range, which is the sub-6 band, and that's the band that we support. Our product right now is release 15 compliant, and we are working to get it to release 16, and it's a part of the roadmap. Couple of things that I would like to point out here is that in this network in a box, we have two operational modes that we've activated. One is what we call the fully functional 5G mode, which essentially means that the gNodeB and the 5G core network are both running simultaneously and provides an end-to-end 5G connectivity to devices. And the other one is the gNodeB only mode, which is essentially the 5G core being deactivated and the product running just in gNodeB mode, just behaving as a RAN box. We have done some interoperability of this network in a box product with a host of UE manufacturers, primarily Qualcomm-based chipsets that we've used. And some of the use cases that we envisage this product would serve, at least in the short term, is the testing and simulation market. And going forward, we plan to enable this product for the enterprises space as well. I'd like to also take a little bit of time and talk about what kind of deployment models this product is expected to serve. Now, as I said, 5G testing and simulation is one of the primary sort of use cases that we're targeting, at least at this time. Which we typically see to be a single box deployment, where the 5G core and the gNodeB running all together in one box, which is kind of illustrated with this with the first diagram that you see on the slide here, with the UE on the one side and the data network on the other side. The Amantya NIAB running the full 5G mode. The second operation mode, the second deployment mode, essentially is a multi-box deployment, which is more suited to an enterprise use case, where you have multiple spots where UEs need to connect from. Therefore, you would typically be deploying the Amantya NIAB in gNodeB at multiple places, and then all be connecting to a single network in a box that is running full 5G mode, which is illustrated in diagram 2. Both of these options are provided as a license-controlled offering for this Networkinabox. One of the other aspects that I'd like to highlight here is, the plug-and-play sort of aspect that we've tried to enable in this box. So what we do is, at the outset, we ship the box out with default configurations already enabled. Of course, before we ship it out, some of the fundamental level configurations also need to be already put into the box, and that we kind of procure by way of questionnaires that we furnish our customers with that they need to fill out. And once the questionnaire, the configuration in the questionnaire is configured, the box can be shipped out pre-configured. The intent is that the box is ready to use with just a flick of the switch. At the same time, we also are enabling software and firmware upgrades that can be done online. And we are also putting the box in with an online license management system, which makes it, which basically would just involve inputting the license in the box or on an online portal, and the box gets activated with all the necessary functionality that's been purchased. One of the ideas, or one of the major driving forces or factors behind us, working on those aspects, is the fact that we wanted this box to be equally appealing for people who are not quite conversant with the way the telecom domain works. So the idea is to be able to just plug the box in, switch it on, and then the UE should be able to latch onto the box and ready to go. At the same time, we also want this box to be usable for people who are conversant or who are comfortable with the telecom domain. And for those users, or power users, as we might like to call them, we've enabled a whole bunch of configurations that they can play around with, in their testing or use cases, or whatever use cases they might be wanting to use the box for. Having said that, I'd like to call upon one of my colleagues who's on this call with me, Ankur. He's going to be talking very briefly about the 5G core, and after that, we'll switch to the demo setup itself and then jump into the demo.
So as Neil has mentioned, we have 5G core from Amantya, which is release 16 compliant, and it is already cloud native, and microservice-based architecture is already implemented on this. So complete solution of the 5G core is actually comprises of control plane, application functions, or network functions, and as well as the high performance user plane function, which is UPS. So the Amantya offering, which is bundled into this NIAB, is 5G SA core, which has management interfaces like REST-based API, then service monitoring, and then for Grafana-based tool for getting the network parameters. Apart from that, so orchestration is done through Kubernetes for all network functions for 5G core, and it is already integrated with third-party gNodeB stacks, as well as if we talk about UE manufacturers, so we have interoperability done for Qualcomm-based chipset UEs.
Thank you, Ankur. Moving to the demo setup itself, this is what the demo setup looks like. At the center of it all, we have the Networkinabox, Amantya Networkinabox, which is currently pre-configured and running in full 5G mode. And you'll see that when we walk you through the GUI itself. On the left-hand side, we have a device. It's a Qualcomm-based handset that we've selected for this for the purposes of this demo, and we've screencasted that device using Visor. On the right-hand side, we've enabled backhaul connectivity to the internet, and we'll be doing YouTube browsing, and we'll also be downloading a file and show you what the data throughput, etc. looks like on this box. On the northbound interface, we have a GUI. So the scope itself is that in the first part will involve us walking you through the user management interface itself. And then we'll use a live UE to latch onto the network, and we'll do data browsing and data transfer. And we'll show you the throughput that is being that is flowing through the box itself. Before we do that, I'd like to very quickly show you what the box itself looks like. And I'm going to be switching on my webcam. Hope you can all see the webcam. So this is what the box looks like. As you can see, it's a small form factor, and we have 4 antennas. We have provision for 4 antennas on this box. We are currently just using 2 of these antennas, but going forward, we're going to be doing this in 2 transmit, 2 receive modes. So we have provision for 4 antennas. On the reverse, on the rear end of the box, there are various ports that we've enabled for various purposes. And we have a port for power socket, obviously, and then we have a couple of ports for Ethernet. One of the ports is used for management. The other one's used for backhaul. And we have a couple of USB ports and an HDMI port for peripheral connectivity, for debugging purposes, etc. That's about it as far as the box is concerned.
Now we start with the login page itself. This is what the Networkinabox login page looks like for any user that's trying to log into the box. So let's log in. This is the landing page. This is the main landing page that any user for the product lands on. Here, right at the center, you can see the topology, the network that is a part that is basically running on this box. Since the box is running in full 5G mode, which means that the RAN and the core are both running in this box. You can see the NG RAN box as well as a host of network functions that comprise the 5G core. All of these boxes are color coded in the sense that all of them are red, which indicates that the nodes are down. And during the course of this demo, we will actually switch the box on, and you'll see the box color coding start to change from red to green, which means that the nodes are coming up slowly. So let's proceed to switch the box on. There you see UPFs come up, and it takes a couple of minutes for the entire box to reboot, but you'll see some of the other nodes also start to change color slowly. The UPF's up. As you can see, all the nodes are now up, which is indicated by the fact that they are all color coded green. The control plane, user plane, and the NG RAN, all of the nodes are up, and the box is ready to take calls. Before we actually move on to a data browsing session, let me just walk you quickly through the various panels that you see on the left hand side of your screen here. The network map is nothing but a link to the landing page itself. So we are on the network map right now. Then there is a subscriber screen as well, which essentially is a list of all the subscribers that you can add on to the box. We are going to be using the highlighted IMSI for the purposes of this call. And I'll show you this IMSI when we are running the call in the Wireshark traces itself. The traffic analyzer is a real-time graph that gets updated when there is data flowing through the box. Since there is no data at this present time flowing through the box, we don't see anything here, but we'll see a graph getting updated in real time when we are doing data browsing. The operation mode is a sort of a system level configuration for the box itself. As I had pointed out earlier, the box can run in 2 modes, the full 5G mode, which means that the gNodeB and the 5G core are both running, which is the mode that we are using for the purposes of this demo right now. And then there is a gNodeB only mode, wherein the core is deactivated, but the box can run and function as a standalone gNodeB only. In addition, we have band configurations available where you can configure different bands that you want to sort of work or test on. We are working with 78 right now and in TDD mode. Going forward, we are going to be supporting FDD mode and a host of other bands also that you can see here. In addition to the operations mode and the band, we are also in the process of enabling quite a few other configurations. There is a provision for on-the-fly firmware upgrade that we are putting into the box. We also plan to have a restore setting available on this box so that it can be restored to the factory setting level. And at the same time, there is a provision for license addition and license management that we are enabling in the box. These things are still work in progress, as a result of which some of these links have been grayed out. Moving on, as I said earlier, our intent is to make sure that the box itself is equally appealing and easy to use, not just for the telecom professional, a person who is aware of telecom jargons and understands how things work in this domain, but also the telecom novice, people who are not quite familiar with how what kind of telecom jargons are used these days, and therefore may not be able to sort of use the box in a whole lot of detail. For them, for telecom novices, we plan to ship the box out pre-configured with all the necessary configurations in this place to enable just a one-touch startup where the box can simply be switched on and the UE is ready to latch on. Of course, some of the fundamental connectivity level parameters are needed to be provided before the box can actually be rendered operable. For the telecom professionals, seasoned people who are aware of telecom jargons, who understand how the domain works, we have also enabled a whole list of different configuration settings that they can play around with. There are settings available for the CU, the centralized unit, the distributed unit, and the radio unit. There's a whole bunch of configuration available here. And so also for the core, as you can see, there are a whole bunch of configurations available for each network function that is running on this box, from connectivity parameters to DNN names to IP addresses, protocols, and so on and so forth. Right, now we move on to the actual demo itself. We have run through the user screen, at least a general understanding of the user screen itself should be available at this point in time. What we will do now is, we already have a UE, a mobile phone that we have selected for this particular demonstration, and this is a OnePlus mobile phone which is based on a Qualcomm chipset. We've screencasted the mobile phone on our laptop, and you should be able to see the mobile phone here on our screens. As you can see, the mobile phone is in airplane mode, which means that it is not currently latched onto any network. What I'm going to do is I'm going to take the phone off of airplane mode, and we will now proceed to select so the mobile phone is now starting to scan all of the frequencies that are available, and it's going to go ahead and build a list of all the networks that it can potentially latch on to. And we could have put this mobile phone in auto mode, but I wanted to demonstrate to you the fact that we are going to be specifically selecting the 5G network that we have earmarked for this demonstration, and therefore we are doing all of this manually. Right, so now we see that the UE has finished searching for all of the networks that it can latch on to. Right up top you can see Amantya Test 5G, which is the 5G network that we have created for the purposes of this demo. I'm going to latch on to it. You can see that the latch on is complete, and it is evident by the 5G icon that you can see right on the top of the mobile phone screen. It's not quite clear, but that's the 5G icon that we were all looking for. What I will do now is I will jump very quickly to the Wireshark traces, and in the Wireshark traces you can see the IMSI that we were using for the purposes of this demo. That's 9. Which matches with the IMSI that we have configured for the purposes of this demo. So it essentially kind of means that the IMSI that we are using is actually the one that we've configured in the box itself. Moving on, we will very quickly run a YouTube video on 5G, just to give you an idea of the kind of user experience that we are looking at. There we go. So it's an 8K video, and if we go to the traffic analyzer and switch it on, you'll see a real-time graph getting generated and updated as data starts to flow. The downlink graph is green in color, as you can see here, whereas the uplink graph is blue. We're running a YouTube video. The nature of YouTube is such that there's a lot of buffering that happens, which is why you see a lot of crests and troughs in the graph on the screen. We'll do another example here. We'll do a file download. So we'll switch the video off and we'll just download a file where you'll be able to see a far smoother graph in terms of the download speed that happens. So we're downloading this file here, and when the download starts to happen, you'll see the graph going up. We are at a speed of about a throughput of about 30 Mbps right now, and we're still moving north. We've reached a speed of 60 at this time.
So as next steps, we'll open up the chat window so that if you have any questions, you can simply ask on the chat box, and our team will answer those. That option is open right now, so if anyone has any question, they can simply put their questions in the chat box. Okay, so the first question that we have here is how many users can be supported in the Networkinabox? So, Indranil, you can take this question.
So right now, we are looking to position this box for testing and simulation environment. So we are currently looking at 8 simultaneous UEs to be connected to the RAN at this point. But as a part of our roadmap, we plan to increase this to 32 before the year is up. That's the plan.
So the next question here is from Chris. Can an external core be integrated with this box? Ankur, if you want to take this question.
Yes, so our Networkinabox is having all BGP interfaces, defined interfaces. So it can be definitely integrated with any third-party core also.
Okay, so we also move to the next question, that is N41 supported or not? So Ravi, if you want to take this question.
Yes, it is supported.
Okay. So we have a lot of questions coming in. So I'll just take a few of the questions here. Okay, so can we use FR1 and FR2 with this box? Indranil, if you want to answer.
Right now, it's just FR1. We are not doing FR2 with this box.
Okay, so we have another question. What is the data plane performance? Ankur, if you want to take this question.
Currently, in our lab environment, we have tested it for 100 Mbps because the radio is also limited, and in future it will be upgraded also.
Okay, so few more questions are coming in right now. So Arthur, from Arthur, we have a question. What have you planned in the roadmap for this product? So Indranil, if you want to take this question.
Yeah, sure. Right now, as I have earlier, we are targeting this for testing and simulation. Going forward, we plan to enable this for the enterprise sector as well, which means that we'll be looking at upping the throughput. We'll be looking at more range, and we'll also be looking at enabling a few features which involve integration with which involve native IMS as well as support for CBRS.
Thank you. So another question that we'll take here is, as you have mentioned that this box is for testing and simulation purposes right now. So do you have any knockdown API interface for integration? Ravi, if you would like to take this question.
Yes, we have RESTful APIs for the same.
Okay. Okay, let me just scroll through the questions because a lot of questions are pouring in right now.
I'll just take a question from EAG, who wants to know about beamforming. So so right now, 2x2 MIMO is a part of the roadmap. We are currently SISO, and we don't support beamforming for time.
Okay, so I can see that a lot of questions are here. Okay. So we have another question here from Xavier. How many RAN can be connected to the port?
So there's no limit actually. You can have as many as of them can be connected to both.
Any other question, if we want to take linearly from the list that you can see here?
So you can reach out to us, AG. You can reach out to the, you can visit our site and reach out to our marketing team, and we'll take it from there.
So there's a question which says that does the core can connect to multiple DNNs? Yes, we have a slice support also. You can have multiple slices and multiple DNN also.
And to answer the question, can we connect to free 5G CIMS? Yes, the answer is yes, because it's standard-based integration that we can do. We've tested it with free 5G CIMS.
Yes, that's correct.
So we'll wait for a couple of more minutes to see if any questions are here. And, just wait for a minute.
No dynamic sharing, spectrum sharing between LTE and 5G. That's not supported. As I said, it does not have native IMS, but it can integrate with a third-party IMS. So based on that integration, VONR can be supported. However, as far as the core is concerned, right now we don't do IMS bearers. We just do default bearers. IMS bearers are a part of the roadmap.
Okay, so I guess most of the questions here are answered with the panel here. And there are a few more questions that are still coming in. So
this has actually been deployed with some of our customers at this time. For NSA, this box compatible with LTE over X2.
So it's on our roadmap for LTE over X2, and
right now, what we've enabled for this box is standalone. NSA mode is has currently not been tested.
So I guess all the answers all the questions are answered here, and
see, at this point in time, the coverage area is limited to about 15 meters. But going forward, when we are looking at deploying this for enterprise use cases, we plan to increase it to about 1,000 feet, which is around 300 meters.
Yes, so AG, you can modify the parameters related to RAN as well as flow.
We have a GUI that we've enabled for exactly that purpose that Ravi was walking you through. All the parameters, as I said, the idea is to ship out the box pre-configured so that it can be stood up with just a flick of a switch. But in case you want to play around with the box and the configuration itself, you're free to do that.
Okay, so I guess all the questions here are answered now. So if there's any doubt or any questions that you still have,
we have not been able to answer, we'll get back to you on those questions in the form of an email that will follow after we are done with this recording.
okay, so thank you, Indranil. Thank you, Ankur, Ravi, and all the participants here for joining in today. So we'll be ending up this demonstration here. And all the queries, as Indranil rightly mentioned, we'll be addressing it after this call. We'll be sharing the video recording as well. And we'll answering the questions offline. Thank you, everyone. Thank you so much.